Okay, for lesson 7 practice problems, what we got here for number 1 is an airplane problem. We got the Westland Lysander was an aircraft used by the Royal Air Force in the 1930s. Here are some scale drawings that show the top, side, and front views of the Lysander, or the Lysander. I'm not sure how to pronounce that. Right, so we got use the scales and scale drawings to approximate the actual lengths of A, the wingspan to the nearest foot, the height to the nearest foot, and then the length of the Mark 1 to the nearest meter. All right, so what I went ahead kind of before I started this video was I kind of measured some things here, and this right here is the exact, I know it's hard to tell, but this thing that I'm kind of pushing around, that is the 10-foot segment right there. So that's exactly the same length. Trust me on that, it is. That's exactly the same length. And I kind of drew it at an angle because this airplane's going at an angle. Now you guys could be, when you're doing this on your own, you might be using the edge of your note card or marking your pencil off or something, or using the edge of a piece of paper. It doesn't matter. But I'm going to use my iPad here, and I'm going to see how many 10 feet sections I can get on there. So that's 10 right there. That's not what I wanted. All right. There's another 10. There's another. And I'm not being perfect here. Nobody's going to be perfect. This, and there's another 10, but that's not going to count as a full 10. That's not going to count as a full 10. So, all right, so we got, all right, so this is 10 right here. This is 10. This is 10. This is 10. And this looks like, I don't know. I'm just kind of eyeballing it. That looks like 2/3 of 10. So 2/3 of 10 is about, 6.66 repeating, or this says round to the nearest foot, so it's about 7 feet. I guess we can put that in there. So that's 10, 20, 30, 40, like about 47 feet. All right, the height of the plane to the nearest foot. Now what I went ahead and did too before I started this video is I kind of just put something that looks like the ground. That line does not represent the length of the plane. That just represents the ground, because you can see that's where the wheel is touching. It's not perfect, but that represents the ground because we want to know the height of it. Now looks like the highest point on that plane is that part of the tail, and so I'm going to measure that point to the ground. And I paused it really quick here because I wanted to make a height segment that was equal to this. And so here it is. I'm dragging around. Now this thing that I'm dragging around is exactly the same length as the 10 feet. So I'm going to drop it over here because I want to know how tall the plane is. So there's 10 feet right there. I'm going to paste another part of it. And there it is. So I don't know, that's about, maybe a half. So you got right here, this is 10, and I'll say that part right there is about 5. Not exact, but maybe probably close enough. So I'll say that's about 15 feet. 15 feet tall. All right. And then the length of the plane to the nearest meter. And now I'm going to use this part of the scale. All right, so this part is nice to do because that's exactly 7 meters. And so I'm going to measure the very back of the plane right there. That's 7 meters. I'm going to paste that again. about, and that's, I don't know, I would say like maybe a fourth, third. I'll just go for a third. And maybe a four. I'll do a fourth, because half of 7 is 3.5, and so 7 divided by 2 is 3.5, and so half of that would be like 1.75. Okay, so all right, so what? That, and so this is going to be 7 plus 1.75. Which is 8.75, but we have to round this to the nearest meter, so about 9. This is in meters, not feet. Okay. So that involved us kind of just doing a little bit of, problem solving, just kind of figuring it out based on, the lengths that we have there, and you can use whatever means necessary that you find you can measure, You can measure whatever. You can even use a ruler. All right. For number 2, it says a blueprint for a building includes a rectangular room that measures 3 inches long and 5.5 inches wide, 5.5 inches wide. The scale for the blueprint says that 1 inch on the blueprint is equivalent to 10 feet in real life of the actual building. What are the dimensions of the rectangular room in the actual building? All right, so that's pretty telling right there. That says that 1 inch, right? 1 inch in the blueprint equals 10 feet. So what we're going to do here is we're going to measure these, or not measure, but we're going to take those measurements that we already have and then multiply those by 10. That's it. All right. So the length is going to be 3 times 10. Which is going to be 30 feet. All right, and the width is, we're going to do, what is it, 5.5? You're going to do 5.5 times 10, and that's going to be 55. I don't know why I wrote out feet. I could just do FT, just abbreviate it. So what are the dimensions of this room? 30 by 55 feet. There we go. All right. And this one right here says, here's a scale map of Lafayette Square, a rectangular garden north of the White House. So for question 8, it says the scale is shown to the lower right-hand corner. Find the actual side lengths of Lafayette Square in feet. So what I am going to do is I'm going to take this and I'm going to measure it right here. So that's 200 feet right there. And I'm going to copy and paste that. All right. Put that right there. That's 200 feet. That's another 200 feet. Whoa. There's another 200 feet. And that looks like about half of 200. Okay, and I'm just clearly eyeballing this. That's 200, that's 200, that's 200, and then I would say this is about 100 right there. So you got 200, 400, 600, 700 feet. And it's also good to kind of remind you that, if you ended up doing this and ended up getting like 710 feet or something because you just saw it differently, you saw that, the 200 part and saw the fraction differently, as long as you're close to what I have, I think, if you ended up with like 2,000 feet, yeah, something's off, but like if you have like 750, maybe even 680, I don't know. But just something close to what I have is probably going to be sufficient. All right. And then we have to do the, okay, I paused it for a second. I know you didn't see any time pass between me pausing it, but what I did was I just measured this. Now this right here is the same length as this. Definitely doesn't look like it, but it is. All right, and then I'm going to measure the other dimension of this garden. So from here, that's 200 feet. Oops, let me copy that, paste it. So that's like 200, and then I don't know. I think I'm just gonna use 200. Why not? I mean, you could put 210. I don't care, but I'm gonna do 200 feet that way. All right. So you use an inch ruler to measure the line segment of the graphic scale. About how many feet does 1 inch represent on this map? Now, I do not have a ruler that I can use, but I do have a measuring device on here. But you guys should be doing your own measuring. But I'm going to measure the scale, so I can put a mark here and I can put a mark there, and it measures it nicely for me. And so it gives me 1 1/4 inches right there. So when I measured that, I got 1 1/4 inches. Which is 1.25 inches. Or 5/4. All right, and so now what I can do is I can just take that number now and I can divide it. So I can do 200 divided by 5/4. So I'm going to keep change, flip, keep 200 over 1, change it to multiplication, flip the second fraction, and then I can cross cancel here. 200 divided by 5 is 40. So that's 160. So that makes sense. About how many feet does 1 inch represent? Yeah, I would say like about 106 feet. And I'm not perfect here, but I'm betting that's pretty close. All right, for number 4, here's a triangle A. Lynn created a scale copy of triangle A with an area of 72 square units. How many times larger is the area of the scaled copy compared to that of triangle A? All right, so let's figure out now. Area of a triangle. Area of a triangle is 1/2 times base times height. You know, but you might have also been told like just do base times height divided by 2, because that works just as well. But 1/2, you know, if you ever look up the area of a triangle or how to find the area, the formula for area of a triangle, you're always going to get, it's always going to give you like 1/2 BH, you know. So it's a very algebraic way of writing it, but 1/2 times base times height. 1/2 times base times height. So what we have right here is we have a base of 3 and we have a height of 3. All right, so you got 3 times 3, which is 9. Okay, and then 9 divided by 2 is 4.5. All right, so this one has an area, A for area, of about 4.5 square units. You know, according to that. And now if I take 72 and divide that by 4.5, let me use my calculator. If I do 72 divided by 4.5, I get 16. All right, so the area is 16 times bigger. 16 times bigger. Now remember, when you do area though, it's not, the area does not equal the scale factor. So the scale factor wasn't 16. The scale factor is going to be whatever number times itself equals 16. So what number times itself equals 16? Well, that's going to be 4 squared, right? So that's going to be 4. So the scale the scale factor was 4. So how many times larger is the area of this? Oh, that was 16. What scale factor did Lynn apply to the triangle A to make this copy? All right, 4. What is the length of the bottom side of the scaled copy? So the length of the original one is 3, and so if the scale factor was 4, that's going to be 3 times 4, which is 12.